This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
They're tunneling underneath this room, are they? Sounds like they are. Alright, so this is the first class, the first week of the financial management course. So we're going to start today with just some information about the course, some general information, and some housekeeping arrangements. So we'll start, we will start with this official kind of announcement that I've been asked to share with you. So to do this first, get this on full screen. Right. Okay, so as you're aware, there are travel restrictions to Australia or between China and Australia. So as many of our students are from China, a lot of them have been affected by these travel restrictions, so they're not here today. So the university is doing their best to facilitate them by providing material online on the internet, and that includes what we call lecture capture, which is essentially a video tape of the lecture. But essentially what my understanding of the videotape consists of, it consists of what appears on the screen. So that is what the image is when the people watch the videotape. But they do hear also the audio. So I have my mic on, so they should hear my voice. And there is a possibility, if you ask me a question, that they might hear what you're saying as well. But I think there's not much likelihood they will be able to see you. I don't think they'll be able to see me. So just, we're kind of legally obliged to let you know that the lecture is being recorded. And some people may have a problem with that, I don't know. If you do have a problem with it, Maybe let me know at the break or after the lecture. But I'm going to proceed on the assumption that we're okay with this. Okay. All right. So I could add a lecture mode here. Skip. What's going on? Alrighty. So we can get into this mode, but I can't get out of it. Okay. Sorry about this. There we go. Okay. Right. Now. Okay. So my name is Morris McCourt. So I'll be your lecturer for the following weeks.
Use the volume, please.
Sorry?
Volume.
All right, okay. Can't. This thing is switched on. Okay, can you hear me? That better? All right. I don't know. I'll try and speak louder as well because I know there's a lot of background noise or vibration. So yeah, I'll try and speak louder and hopefully the mic will work as well. Okay. All right. So my name is Morris McCourt. I'll be a lecturer for this course for 12 weeks. My office is in the Spot building, which is just down the street here. I'm on the 12th floor. You can come and visit me. I have office hours. If you have questions or concerns, or I have an office hour between 2 p.m. and 3 p.m. on Thursdays. So you can actually make an appointment on the LMS. So there's, if you go to your calendar on the LMS and you do find appointments, I think there's a little button, you should be able to see a list of the slots, the meeting room slots that I have available on Thursdays between 2 and 3. So I've divided them into 15-minute slots. Okay, so please try and make an appointment before coming along because it's useful for me to be able to see who's coming and be able to schedule accordingly. So obviously people listening to this recording may be not here in the lecture room today. So for those guys, I will be enabling them to contact me by Skype or by phone. So again, for those guys who are remote and affected by the travel restrictions, they can send me an email and I will set up a time slot for those guys to have a Skype call or some other kind of teleconference, okay? So, yeah, so that's my contact details. Let's have a look. What's next? Okay, so the format of each lecture will be like this. So the class is typically officially a 3-hour class, but the class actually starts about 5 minutes after the official starting time, and that's really to allow students to get here. They may have classes in other parts of the campus and they have a long way to walk or whatever. So we start at 5 minutes after the official hour. Then we do, the first part of the class will be a workshop where I go through workshop solutions. So what that involves is each week we cover a topic in class, and then there are workshop questions associated with that topic, and they're available on the LMS. So we encourage you to do the workshop questions, and then the following week, at the beginning of the class, we go through the solution for the previous week's workshop. Okay? So that means that today we don't have a workshop because we haven't covered anything yet. But next week we will start having the workshops, and that will take up the first hour or so of the class. And then we start the lecture, and that's about a 30-minute lecture initially until 1 hour, 30 minutes after the class starts, and then we take a 15-minute break. And then we have another hour and 15 minutes, an hour and 30 minutes, sorry, an hour and 15 minutes class or lecture after that, okay? So what are the goals for the course? The goals for the course are to introduce you to finance. So we're not assuming anybody knows a lot about finance, but there may be people who do know a little bit. Is there anybody here who studied finance or accounting in a previous life or a previous course? Yes. Okay, not too many. So, those guys will have a bit of an advantage, but most people seem to have little or no prior financial knowledge. That's okay because we're not assuming any significant knowledge of finance, okay? So what will you learn? Well, we'll do terminology. There's a lot of vocabulary associated with finance. So we get you accustomed to using some of that. There'll be some basic maths, problem solving. And so the types of problems we'll be looking at will be the types of problems that businesses face when they're deciding whether to invest in a project. They need to evaluate a project to see from a financial point of view whether it's worth investing or not. So there's this investment decision-making process. And then associated with that, there's also, once the firm has decided to invest in a project, the firm needs to decide how it's going to fund that investment. Are they going to use their own cash? Are they going to borrow money from a bank? Or are they going to sell equity to fund the investment? So there's two types of decisions there. There's the investment decision and the financing decision. And we'll go through these corporate decision processes in a lot more detail in this course. We also take the perspective of an analyst, and for example a stock market analyst, and they're looking at the price of the stock in the stock market, and they're trying to decide, is that price too high or too low? Is the firm overvalued or is it undervalued? So we look at some techniques for pricing, for finding the value of a firm from an analyst perspective. And some of these things that we cover in class, they may be focused towards corporations or analysts, but they may also be useful in your personal lives when you're trying to decide, for example, do you want to buy a house? Do you want to get a mortgage? Do you want to rent a house? Which makes more sense? So you can use the same techniques and the same processes to, evaluate those kind of decisions. And also, when you're investing in funds, you'll be able to, after this course, you'll have some knowledge of how to evaluate a mutual fund, for example, to invest in for your pension, okay? So any questions so far? Feel free to interrupt me if you have any questions that occur to you. Okay, so how does the assessment work? Well, we have 2 group assignments, and each group assignment is worth 10%. The first assignment is due the 7th of April, so in about a month. So these are group assignments, so we hope, we'd strongly recommend that people work together as a group to complete these assignments. We have a maximum of 4 people in a group. So we've already created some slots for groups on the LMS, so you can add yourself to a group on the LMS under the People tab. But given that many of our students are not here in Melbourne and they're not physically able to work together, we're also going to accommodate groups of one. So if people if people can't form a group, or for one reason or another, they have some problem connecting with other people, they can work in these group assignments as individuals. So, yeah. So each of these assignments were 10%. Then in week 8, we have a midterm semester exam, and that's a 1-hour exam. It's a multiple choice exam, okay? And then in June, during the exam period, we will have a final exam, and that will be worth 60% of your grade. So this subject has what we call a hurdle requirement, and what that means is no matter how well you do in the assignments and how well you do in the mid-semester exam, you're going to have to pass, at least get 50% in the final exam, okay? So just be careful with that. And just to illustrate this, I'll just to make this abundantly clear. So you've got assignment 1, assignment 2, the mid-semester, and the final exam, okay? So let's say you get 80% in that, 80% in the second assignment, 80% in the mid-semester, and 40% in the final exam, okay? So what does that map into? Well, you get 8 marks for that, 8 marks for this, 16 for the mid-semester, and for the final exam, that 40% will translate into 24 marks. So you'd be looking at this, and you'd think, okay, you've got 56 marks out of 100, so you've done okay. But because of this hurdle requirement, you've gotten less than 50 here in the exam. So because of this, your mark here is going to appear in your transcript as 49, okay? And the grade will be this thing here, NH, all right? So just be careful with this hurdle requirement. Okay. So the textbook for the course is Burke and DeMarzo. So there are a number of copies of this in the library. So we followed the book fairly closely for specific chapters and specific sections. And for each lecture, I'll tell you what chapter and sections we're covering in that class, okay? So I do strongly recommend it to read the book. There's a lot of, the book is very well written. It's very, there's some useful examples and material there that we don't necessarily cover in the lecture. So I recommend that you do read the book. So the book is in the library. So there's about, I think, 16 copies in the library. But there's also an e-book. So for our remote participants, if they can log into the library catalog, they can actually access this electronic book, and there are 3 copies of that available for students who can't, for one reason or another, access the paper copy. So we would ask the students in Melbourne maybe to use the paper copies of the book and to keep the 3 e-books for the students in China. Okay. So speaking of online resources, so this is just a brief summary of what's available online for this course. So we do have a new learning management system. It's called Canvas. You've probably logged into it and had a look around already, I hope. If you have any problems with the system, there is 24/7 support, okay? So every week, the lecture slides will be available. So these slides here that I'm showing you today will be available before the lecture. And then, as you can see, I mark up the slides with my magic pen here, and I'll actually save those slides in another PDF, and I will post them on the web as well, so that you can actually see anything we write on slides during the class, okay? So that's what I mean here by markup slides. The workshop problems are also already available on the LMS for each lecture. So when we go through the solutions will not be available, so we go through them in class first. But after we've completed reviewing the solutions with all 3 streams, then the solutions will be available on the LMS. So this course consists of 3 different streams. So I've got 3, I have this group here, you guys, and then I have 2 other groups of a similar size who I teach on Mondays and Thursdays. So after the Thursday class, I'll make the solutions available, okay? So we've already also discussed the lecture video capture, and the lecture video capture will, of course, include the workshop. So the video capture is available on the LMS pretty much about 30 minutes after the class is over. So there'll be the video capture for each of the 3 classes that I teach per week will be accessible on the LMS. So we have also the library book that we discussed already. And then we have this thing called the online tutor. So let's talk a little bit more about that. The online tutor is basically a Q&A kind of discussion board, and it's monitored by 2 PhD students who are assisting me with corrections and things for this course. So what the online tutor allows you to do is to ask questions about course materials, about the lecture notes, about the workshops, about the assignments, so kind of technical. It's meant for technical questions. So you can make use of the online tutor to ask your technical questions, and my 2 tutors will respond to them. If there's any issue that they can't deal with, then they will come to me. Okay? So we do ask you not to send us an email about technical questions. Rather, you should use the online tutor if you have questions about the lectures or the exercises. Then and also if you need to, you can just make an appointment to see me during my office or some other time. Okay. So the other thing about the online tutor is, we've had issues in the past where students maybe have taken advantage of the system. A couple of years ago, we had a guy who 2 days before the mid-semester exam, he posted over 100 questions on the online tutor, okay? So please don't do that. It's kind of, our system is not designed for that kind of situation, okay? And also make sure you read your questions first, because sometimes students post questions and it's not terribly clear what they want. So make sure you read it a couple of times to make sure it captures exactly the problem that you're having, so that there's not this toing and froing between the tutor and people asking the question. So it's much quicker if the questions are posed kind of carefully and thoughtfully. Yeah. Okay. And also the questions can be anonymous if you wish, or you can actually, if you want, you can sign them, so we know who it is. But other students will be able to see the questions that you post, and will be able to see the answers that you post. Okay. So just be aware of that. If you're a bit shy, you might want to stay anonymous. If you're not so shy, you can put your name there. Okay. Okay. So the calculator, you will need a calculator for the exams. So you will have, the exams will be problem-based. I mean, they're not going to be very hard problems, and the maths isn't going to be very complicated, but it will speed things up a lot if you have a calculator. So there's only one model of calculator allowed in the exam, and the model is this one, the Casio FX82. But there are several variations or suffixes of that model that you can choose. but the basic model must be this Casio FX82, okay? So I strongly recommend you buy a calculator and bring it to the exam with you, because there won't be many calculators available in the exam. There might be one or two calculators available, for students who forget their calculator, but I wouldn't be relying on using one of the calculators in the exam room. And also just be aware that the guys walking around the exam or running the exam will be doing spot checks to make sure you've got the correct calculator. Okay. So this is the schedule for the course. These are the topics we'll be covering. So it's a 12-week course. There will be 11 lectures starting today. And the mid-semester exam, as we said earlier, is going to be in week 8. So you're probably wondering what topics we're going to cover in the mid-semester exam. Well, we'll probably almost certainly go up as far as stocks. And I haven't written the exam yet, so I'm not sure whether I'll include risk or not. I'll decide closer to the time and let you know. Okay? Any questions so far? Okay, great. I believe it's okay. So one other novelty we're going to do this semester is, you're all aware that University of Melbourne is one of the top-ranked universities in the world. And there are two main reasons why that is the case. One reason is because of the quality of the graduates that we produce and the success that they go on to have in their careers. The other is the one that we're also evaluated on by the people who create the rankings is the quality of the research that we, the professors and the lecturers, produce in the university. Okay? So we realized that there's very little kind of overlap between the two. So in an attempt to address kind of the gap between the teaching and the research, we decided we would try a little experiment this year for the first time. And the experiment is that we will show very short videos of the professors, the lecturers in the finance department talking about their research work, okay? So the topics that they will talk about have been chosen to relate as closely as possible to the topics that we cover in this class. So it will be relevant to the material that we cover in class. But hopefully it will kind of stimulate some thought about the value of research, how it relates to finance, how finance is not kind of already a fixed body of knowledge, it's kind of continuously evolving, and how the University of Melbourne is contributing to the evolution of finance as a topic. Of course, the topics, the contents of these videos, we won't be assessing people on what's on the videos, okay? All right. Okay, so that's more or less the end of the housekeeping section. So if there are no questions, we'll move on to the lecture, okay? So I just grab my notes to make sure I don't have to go working or something with it. Okay, so in today's lecture we're going to cover, pretty basic concepts, but they're important concepts and they're key to understanding what's going on in the rest of the course, okay? So we're going to talk about the concept of present value and the time value of money. We're going to talk about arbitrage, And we're also going to talk about risk. And the chapter that we're kind of covering today is this chapter 3 in the Burke and the Marxo group. Okay, so let's just talk briefly about finance as a whole. You know, finance is a very broad topic. And I mean, you can get a sense of that if you just look at the research areas that some of the faculty in the University of Melbourne are studying. So let's briefly just have a look at some of these. So you have corporate finance, which we've discussed already, where you have this, you know, the investment decision made by a corporation, whether to invest in a new product or a new firm or a new factory, or indeed just close down a firm or a factory. You know, so those kind of decisions all involve finance, obviously. And then we have the financing decision, whether the firm uses their own cash, or whether they borrow money, or whether they raise equity. Okay, so corporate finance is the first topic there. Then we have asset pricing, which is the analyst view, where we're looking at ways of valuing stocks and bonds. And the holy grail here is to be able to try and predict the value of a stock or a bond in the future. So you'll see it's extremely hard to do that. But it doesn't stop people from doing a lot of research work to try and do that. So we have some models about how to value stocks and bonds, and in this course we cover some of those models, but they're not perfect and there's room for improvement, as you will see. Then we have people looking at financial markets, basically how stock exchanges work, how buyers and sellers meet, how they complete their transactions, and the costs associated with transactions. Then we have banking and insurance, which probably are the most everyday topics that we're already aware of. Then we have personal and household finance. So there's a lot of work going in now to understand how households manage their finance. How much money do they borrow? How much money do they save? How much money do they invest in stock markets or in funds? And you know, what are the risks and what are the outcomes of those activities, that behavior by households? Okay. Then we have a relatively new area of behavioral finance. So that relates to human psychology and how that affects the decisions that people make about their money. So you find that we're aware that people do not always make optimal decisions. They don't make decisions that maximize their wealth. Sometimes they make decisions that destroy their wealth. And that's often kind of unconscious behavior as people, as humans. And so that's a very interesting area of finance, and it's kind of growing rapidly in recent years. Then we have climate finance. So we're seeing a lot of interest now in trying to understand how climate events affect, for example, stock prices, or how it affects households. So you have a lot of research going on climate and the relationship to finance. And we have, of course, investments. So we need to understand more about how mutual funds perform, what are the risks, what are the benefits of investing in mutual funds. Real estate is kind of a huge area of research in finance, houses and property, art. You know, there's a whole plethora of alternative investments. Could be wine. You know, so the idea here is that, you know, finance is a very broad topic. So the next question then is, you know, how do we, as researchers, as students, kind of get our arms around that topic, and you know, where do we begin if we're trying to study? Okay. So if you distill finance down to its core components, you know, finance boils down to two core components. It's money and time. So how do money and time relate to each other? And the key things we want to look at are you know, if we pay some amount of money today, we want to know how much money we receive at some future point in time. And alternatively, if we want to know as well, if we receive some amount of money today, you know, how much will we have to repay at some point in time in the future? Okay. So, in this particular case, sometimes people find it a little unintuitive. Can you think of any example where we receive money today and have to pay some money in the future?
Borrowing money.
Yeah, a loan or a mortgage. Where a loan, when you make a loan or a mortgage, you receive the money today, and then you have to pay the interest payments and repayments in the future. Okay. So that's the core of finance, is this relationship between money and time, and that's our starting point for this course. Okay. So let's do a little thought experiment. So imagine you have $100, okay? And you have to make an investment in one of these three options here, okay? So the first option is you can receive $100 in cash, okay? And they receive that today, right? The second option is you get the promise of $100 in 5 years. All right. So somebody promises you today that they will give you $100 in 5 years. And the third option is another promise, only this one is where they promise you to give you $100 in 1 year. So let's start. The first question is, which of these options would you prefer to invest in today? Yeah. So most of you, if I hear correctly, would choose the first option, the $100 in cash. Okay. There are no right or wrong answers here, by the way. This is just to stimulate a thought here. Okay, so we prefer option 1. That's our first preference. What would be our second preference? The third one? Okay, so the third one is the promise of $100 in 1 year. So why is that preferable to the second one? Time. Yeah, so this is what's going on here. So we prefer cash today to receiving cash in 1 year's time. And we prefer to receive cash in 1 year's time rather than cash in 5 years' time. So why is that?
Because money loses its purchasing power.
Okay, so you're thinking about inflation and something else? Sorry?
Because of interest.
Interest, yes, interest. Okay. But is there anything more? Why do we get interest on our money? Why, if we put, $100 in the bank, and the bank says, "I'll give you $110 next year." Why do they do that?
They're making money off your money.
They're making money off your money.
Some value cash.
Yes, but from your point of view, from you as an investor, I think it goes to something more fundamentally human. This second option is a promise, whereas the first option is cash in our pocket. Okay, so the promise of receiving cash in a year's time is obviously worth less to us on a human level than actually having the cash now. If we have the cash now, we can go to the theatre, have dinner with friends, but we can't do that with the promise of $100. You can't spend that money. And, as human beings, we have a finite life. We're not going to be here forever. We might get hit by a bus tomorrow, in which case the promise of $100 next year is of no value. Okay, so even on that human level, having the $100 today, it's better than getting $100 in 1 year. And therefore, that's why I believe we have interest rates. One of your friends mentioned interest rates. So if a bank, they want you to give them their money, essentially they want you to lend them $100, but in order to induce you to do that, you need some compensation, okay? And that compensation is interest, okay? And that can be traced back to this kind of fundamental human need to have something now, okay? And then you can extend the argument and you can say, obviously, as humans, we know there's better chance we will be around in 1 year than we will be in 5 years. So therefore, the promise of receiving $100 in 5 years is worth less to us than the promise of receiving $100 in 1 year, okay? So that's what we mean by the time value of money. It's a very kind of philosophical thing nearly to do about our existence and the human condition, okay? So then if you think of the price, so let's say, how much would you pay today for each of these options? You have your $100. So how much would you pay to receive $100 in cash? Today, you probably would pay $100, surely? No? It makes no difference. You would be indifferent. Okay, so I think, the price that you would pay, obviously you'd pay more for the first option again. And then, I could do this wrong. I have it wrong. Sorry, excuse me. I put these in the wrong way. Okay, so, if somebody, how much would you pay for the promise of $100 in 1 year? So, you'd pay less than $100. So, again, it's going to be less than this. Sorry, I better get the number right this time. And then, again, for the third option, so we won't labor the point here too much. But the idea here is to show that, you're going to pay less for the option, for the promise of receiving money in 5 years than you would for the promise of receiving money in 1 year. And, you're never going to pay more than $100 for those promises. And then there's another way of looking at this puzzle, which it's not really a puzzle, but it's an experiment. So let's say the person making the promise to give you $100 in 1 year is Tim Cook. He's the CEO of Apple. You know who Tim Cook is? Mm-hmm. Right. So Tim Cook comes along to you and he says, look, we're developing a new product. We're kind of short of cash. I need to borrow $100 off you to fund this product development, okay? If you say yes, I'll get my lawyers to draw up a contract and we'll sign the deal today. So, I mean, would you give Tim Cook $100?
Yeah.
You probably would. Okay, but what if I came along and I said, look guys, I'm a bit strapped for cash, I promise I will give you $100 next year. How much will you give me today? Okay. So I'm obviously somebody you've just met, just walked in the door. You don't know who I am, or at least not yet. Would you give me the same amount of money that you would give Tim Cook?
No.
No, you wouldn't. Do you not trust me?
Not as much as Tim Cook.
Yeah. No, but you're right. So what I'm trying to illustrate here is that this promise of $100, the price you would pay for that promise varies on a lot of different things. It depends on who's making the promise, how much you believe them. And it might be that, this girl gives me $80 for the promise of $100 tomorrow, whereas this guy, he doesn't believe me at all, and he'll only give me $50 today. So you have this kind of range of, depending on, again, coming back to human nature, about how we envisage risk, how believable we find these promises. There are some people who are more risk-seeking. They think $100 in a year. If I pay $80 today, that's a good return, and they would be happy with that. But then there are other people who say that's a crazy deal. I'd only give you $50 today for your $100 in 1 year. So people are different. So they have different levels of risk aversion or risk seeking. Okay. So that's what I'm trying to get through on this very simple thought experiment. And really the rest of the lecture will be just kind of formalizing these kind of concepts a little bit. Okay. So when we talk about these payments that we receive or that we make, the term we use is this thing called a cash flow. I'm sure you've all heard of cash flows. So cash flows, an investment may be considered a series of cash flows. Some of them may be positive, some of them may be negative. And cash flows can be uncertain. And there are different dimensions of uncertainty. We don't know how much the cash flows might be in the future. We don't know when they're going to be paid. We may not know when they're going to be paid. We may not know even if they're going to be paid at all. So when we think about cash flows, we're thinking of a series of payments, and we're also thinking about how certain are we that those cash flows are going to occur. And just a quick note on notation. So we'll be using this kind of notation quite a lot. So we're going to say time 0 is typically today, right? And then we have time 1. So time 1 can be in 1 month or 1 year, or and then these cash, can go on forever, or they can be fixed period cash flows. If you've fixed cash flow, it comes to an end. If it goes on forever, you might see an arrow like this. And then the cash flows can be positive. And when you have a positive cash flow, that's when you're receiving money. So that's what we would call a cash inflow. And then cash flows can also be negative, right? So that's when we're making a payment, and that's what we call an outflow. So just a quick note on the notation. Okay, so relation to the time and money, we have these further fundamental concepts in finance. So in the book, they talk about the present value and the time value of money. So we've already discussed that a little bit in our thought experiment. Why we prefer to receive $100 today than $100 in 10 years. Then the second fundamental concept we cover today will be arbitrage. So arbitrage is defined as the act of buying or selling equivalent goods in different markets to take advantage of a price difference. Okay, and I'll give you a quick real-world example of what we mean by arbitrage here. So during the week, you know, as the news about the coronavirus kind of kept growing and growing, you know, myself and my wife were at home, we were chatting and thought maybe we should get some hand sanitizer. You know, that stuff that you use for keeping your hands clean when you're not able to wash them. So I was sent down to Chemist Warehouse to get some hand sanitizer, and eventually I found it, but there was actually very little there. But there were 1 or 2 bottles of this particular brand of hand sanitizer, and they were going for, you know, $500 for a very small bottle. Sorry, $5 for a very small bottle. So I thought, well, that seems a bit cheap. Surely we can get it on the internet for less than that. So I go home and I go to eBay, and I see the exact same brand and the exact same quantity on sale for on eBay for $10. Plus post and packaging, so you have to pay extra for the post and packaging. So that could be an arbitrage opportunity. That's where you go to Chemist Warehouse, you buy the hand sanitizer for $5, and then you go to eBay and you sell it for $10. Okay, so that's what we mean by arbitrage. Okay, so buying and selling equivalent goods in different markets to take advantage of a price difference. Okay. Alrighty. So let's have a look at, I think we're going to look now at time value of money in more detail. Okay. So a quick example is our $100 again. We have $100. We go to the bank and they offer to pay us 5% interest rate. Okay. So what does our cash flow diagram look like? So here in time 0, here in 1 year, time 1. So we have, so the bank wants us to deposit our money. So we have a cash outflow to the bank of minus 100. What do we receive in 1 year? We receive $105 back. Okay, so we have a 5% interest rate. So in 1 year we get so this is our the most fundamental example of the time value of money in the bank. Okay. So let's look at it from another perspective. Okay, so in this perspective, you're going to receive $100 in 1 year. So you go down to your bank and you ask them, okay, I'm going to have $100 cash inflow in 1 year, but I don't have any money today. So how much money will you lend me? Okay. So we draw our diagram again. So 0 and 1. 0 is today, 1 is in 1 year. So we know we're going to have $100 in 1 year. Okay. So the bank looks at this and they say, well, actually, you can pay me $100. So then you'll have a cash outflow. And in return for that, I can give you today $95.24. Right? So at R is equal to 5%. Okay. So this introduces us to this concept of the present value. So we have this $100 next year. So that's kind of the future value. And then, so the present value of that cash today is this value here, so our $95.24. Okay. So, you know, another question you might ask, is it reasonable that the interest that we earn on a deposit is the same as the interest that we pay on a loan? And remember, depositing money is the same as essentially lending it to the bank. So if you go down to your bank and you ask them, what interest rate will you give me for a deposit and what interest rate will you give me for a loan, they're going to be two very different numbers. And actually the money you have to pay the bank for a loan is going to be a lot higher, usually, than the interest rate that they will give you on a deposit. But that's generally true for people like us, for you and me as individuals. But if you're a corporation and you're borrowing, hundreds of $1 million, on a daily or weekly or yearly basis, you find that the interest rates are very close. So the deposit rate that a corporation receives is very similar to the borrowing rate that they have to pay. So in this course, we're generally going to assume that the borrowing and deposit rates are the same. So it's not, on a retail level, it's not a very realistic assumption, but at a wholesale or corporation level, it's reasonable enough assumption. Okay. Okay, so we have this notion of the present value and the future value. So we have our PV and our FV that we've seen already. And so how do we find these numbers? Okay, so on this slide we have the first formula for the course, that the present value of a future value is the future value divided by 1 plus the interest rate, 1 plus R, okay? So there are a couple of key things to note or to recap, just even looking at this very simple formula. And the first one is that the present value is decreasing as R increases. So what this means is, that the present, as this R here increases, so we might get a little arrow there, then the present value decreases, okay? So that's kind of intuitive enough. And then the second key point here is this one, where the present value is decreasing the further into the future the payment is made. So that kind of relates to our thought experiment where the value of receiving $100 in 5 years is worth less than the value of receiving $100 in 1 year. So let's just, to illustrate that a little bit better, let's look at our cash flows. So let's look at a 2-year time frame. So we have time 0, which is today. We have time 1, which is next year, and time 2, which is in 2 years' time. So in the case where we receive $100 next year, what is the present value of that? It's $95.24 that we've seen already. But what about the scenario where we receive $100 in 2 years' time? So what is the present value of that? So we have to bring this $100 back to year 1. So what's the year 1 value of the $200 payment that you receive in 2 years? $95.24. So what is the year 0 value of that then? What is the present value of that? It's going to be 90.7. That's my numbers, if I remember correctly. So let me just make sure I have the numbers correct. Yeah. So where does that 90.7 come from? Well, it came from this formula here. So we know that in year 1,
we know that in year 2 we're going to receive this $100, and the year 1 value of that $100 is 95.24. So 95.24 will be our year 1 future value, and then we divide that by 1 plus the interest rate, which I think is 5%, and that's equal to 90.7. Right, so that's where our 90.7 came from. Okay. So any questions so far? We're all good? It's all very basic stuff. Okay. So, the examples we've covered so far are pretty basic examples where we've just typically had a single payment, a single cash flow in the future, exactly 1 year in the future. And we've also assumed delivery with certainty. So this is a kind of a key thing, a key point to note here, that, when we see that the cash flows are going to be delivered with certainty, we always use the risk-free interest rate, okay? So you'll see this in the problems that we set. Sometimes the problem will say, you're going to receive this cash flow with certainty, so therefore you should know immediately that means we use the risk-free interest rate, okay? So where do we get the risk-free interest rate? Well, typically we use the interest rate provided by a bank, for example, to borrow money, okay? Or a similarly credible source, okay? So, yeah, so when you see delivery, a cash flow is certain or is definite, or you use the risk-free interest rate, okay? So, we could make things a lot more complicated. We could have cash flows or investments that have multiple payments, that have multiple cash flows. We could have investments where we don't know the timing of those cash flows, and we could have situations where you don't know if or when the cash flow will occur. So we will look at those kind of situations as the course goes by. But today we're going to focus on very simple scenarios, okay? And then finally, just to illustrate, that sometimes this notion of the present value, you have to be careful with it. So if you see this kind of a situation here, right, where you have the cost, looking at the San Francisco Bay Bridge, which was rebuilt in 2004 to make it earthquake safe, and the cost of that reconstruction was $3 billion, okay, in 2004. But at that time, the engineers estimated that if the project was delayed, the cost would rise by 10%. So if the interest rate were 2%, what would be the cost of that delay in 2004 dollars? So how many people think the cost of the delay costs $300 million? Okay, good. So you're paying attention, I hope. Okay, so the cost of the delay, when you look at this number 3 billion and you see this number 10%, and you think that the cost of the delay in 2004 is going to be 300 million. But that's not the case because of this time value of money. So let's look at what's actually going on here. So we have, let's do our cash flow diagram. So you have time 0, let's say that's 2004. And you have time 1, and that's 2005. So you pay, the cost today is going to be $3 billion. So, if the project is delayed, the cost will be 3.3 billion. Okay. So we look at this 0.3 billion and we think, oh, that must be the cost of the delay. But no, we have to look a bit further than that. we have to take into account the time value of money, and we're given the information that the interest rate in 2004 was 2%. So we have to find the present value of this 3.3 billion, okay? Using a rate of 2%. And that comes back to 2004 dollars of 3.256 billion, okay? So that means that the actual cost of the delay in 2004 dollars, sorry, I've got a 3 there, was 235.6 million dollars. Just stick this in here. Okay. So just be careful with these kind of questions. You just have to. And the key point here is that you can't compare a cash flow in one period with a cash flow in a different period. You have to make sure that the cash flows, if you're comparing two cash flows, you have to make sure that both cash flows occur in the same period. Okay. So that's a key point relating to the time value of money, and that's why we spend so much time thinking about the present values to try and make all these cash flows come back to a point where we can compare them realistically. Okay. All right. So our R here was 10%. Okay, going forward. So the next concept relating to present value is this thing called the net present value. Some of you may have heard of this already, and it's a very widely used concept in finance, and you're going to be computing the net present value a lot during this course. So the net present value, it basically represents the cash that you have or will receive today if you invest in a project. Okay, so it's literally the money you will get in your pocket today if you invest in a project. So the net present value consists of two components. The first component is the present value of the benefits of the project, the positive cash flows associated with the project. And then the second component is the present value of the costs. Okay. So to get the net present value, you just simply subtract the present value of the costs from the present value of the benefits. And that gives you the equivalent amount of cash today that you would get from an investment. Okay. So let's look at a little example. So we have this project where the cost today of investing in the project is $500, and then in 1 year from today, the project will yield $550. Okay. So here we're given the information that the $550 will be paid with certainty if the investment is made. So what interest rate can we use for this problem? We can use the risk-free interest rate because we're told that the payments, the cash flows will occur with certainty, okay? So we know this is a risk-free investment. Okay, so what is the net present value? Okay, so we know here's the NPV formula. It's equal to the present value of the benefits minus the present value of the costs. So let's work out each of these. So let's start with the easy one. So what's the present value of the costs? It's $500 exactly. So we don't have to do any changing on that. So what about the present value of the benefits? Yeah, so it's going to be $550 we're going to receive this $550, and then we have to find the present value of that $550. So we divide it, use our formula where we divide it by 1 plus the interest rate, and that gives us 509.26. Okay, 509.26. So what is our net present value? It's 509.26 minus 500, and that's equal to $9.26. So what that means is that this project, if we invest in it, is worth $9.26 to us today. Okay, so that is a good thing. It's a positive net present value project. So that means that it's an attractive project and it's worth investing in it. Okay, sometimes these net present values are negative, and obviously you're not going to invest in a project that has a negative net present value, because that's going to reduce your wealth. You would need to be a very irrational investor to invest in a negative net present value project. That doesn't mean people won't do it. They might still. Okay, so this is a very simple scenario. You just, for example, you're using your own cash to invest in this project. Okay, so let's look at the situation where you don't have any cash today to invest in this project. So what do? You want to invest in the project, so you go to your bank and you ask your bank, okay, will you lend me the money to invest in this project? Okay. So what happens in that scenario? So let's have a look at our cash flow timeline. So we've time 0. In time 0, we make the project requires it to make a $500 investment, and then in time 1 we will receive this $550 cash outflow. So let's say we tell the bank we're going to receive $550 next year. How much money will you give us today, for that cash flow? So the bank says we will lend you $550. So next year you have to pay, let's make this a different color. Okay, so you have to repay the bank $550 next year. Okay, so how much will the bank lend you for that repayment? So the interest rate is 8%. So the bank will give you $509.26 today. Okay. So 550 divided by 1.08 is equal to 509.26, okay? So literally, on the basis of this investment, you started with 0 in your bank account, but now you have, after you make the investment, you will have $9.26 in your bank account, okay? So that's been, that's good, isn't it? That's good. Now there's another way that you could talk to the bank. And the other way that you could talk to the bank is you could look at it in time 0, I have to pay $500, okay, to make this investment. So could you lend me $500 today? Okay, so the bank says, okay, I will lend you $500. And then in 1 year's time, you have to repay the bank. How much do you have to repay the bank? $540, right, okay. So that means in 1 year's time, so you have this negative cash flow $540 where you have to repay the bank. So how much will you have in your account? You'll have $10 in 1 year's time. But what is the present value of that $10? Any guesses? It's $9.26. Okay? So what I'm trying to illustrate here is, the net present value doesn't change. The net present value of the project doesn't change, irrespective of how the project is financed. Okay? So you could finance the project using your own cash, which is kind of what we did on the previous slide. Okay? So here, in this calculation, we're assuming you're using your own cash. There's no borrowing going on here. Or, if you do use borrowing, the net present value is the same as if you used your own cash. So this is an important kind of concept or principle in finance, and in fact, it's actually a Nobel Prize winning concept, believe it or not, but in a much more complicated context. But what we're saying here is that whether you use your own cash or whether you borrow the money, or let's say you raise equity some other way, that doesn't matter. It doesn't affect the net present value of the projects that you invest in. So this is what we call the separation principle. Yes?
Sir, I'm sorry. I still don't get how we get the green $9.26. The green one.
This one.
Yeah.
Yeah, so it's basically 10 divided by 108. So the net present value of $10 is 10 divided by 1.08. Okay? All right. So good question, and I should really write that down. Yes, somebody at the back there.
Yeah, I have a great question. So in the first scenario, we're assuming that we are borrowing from the bank, but the bank is giving us interest.
No, the bank is not giving, we're paying interest to the bank. So when in the first scenario, we borrow $509.26 from the bank in year 0, okay? And then in year 1, we repay $550 to the bank. So, 8% of $509.26 plus $509.26 is equal to $550. Okay. Any other questions? My maths all right. Okay, so we're talking about the separation principle here. So it's an important one, and one we will encounter again during this course or later in the course. So the separation principle basically states that the decision to invest in a project should be separate from the decision about how to finance the project. Okay. So when you're looking at a project or a product, whether you develop a new product or not, you estimate the net present value, independently of how you are going to invest or finance the development of the product. Okay, and the key thing here is that whether we use our own savings or whether we use borrowings or whether we raise equity some other way, that doesn't matter. So these kind of security transactions, borrowings, deposits, in a normal market, neither create nor destroy value on their own. Okay. So we can look at the NPV of an investment decision separately from the decision about how to finance the investment. Okay. Now another key caveat here is this. I'll come back to you in a second. Is this notion of a normal market? So later in the course, we will consider markets that have frictions, what we call frictions, that basically affect
separation principle. And in some cases, there may be advantages to using debt. For example, tax is viewed as a friction, and when you pay interest, when a firm pays interest, they can deduct the interest payment from their tax bill, and so that makes it advantageous to borrow money to finance a project. But here, when we talk about a normal market, we're saying there are no taxes, there are no frictions. You can borrow and lend money at the same interest rate. There are no other costs. Okay, sorry, you had a question.
So this situation will happen on a risk-free scenario?
Not necessarily, no. The separation principle is not conditional on risk-free. What is conditional on risk-free is the interest rate. Okay. So, for example, if this we're told in the question or in the setup that this $550 cash flow is certain. It's going to happen for sure. Okay. So because we know that cash flow is definitely going to happen, we can use the risk-free interest rate. But if there was some risk about the cash flow, we couldn't use the risk-free interest rate. The interest rate we'd have to use for these calculations would be higher because there's some risk associated with this cash flow. But that doesn't, well, obviously if there is risk associated with the cash flow and the interest rate is higher, then it will affect the net present value calculation. Yes. But it doesn't affect the mechanics. It doesn't affect the formula that we use to calculate net present value. Okay. But it will affect this interest rate. So for a risky cash flow, this interest rate might go up to 15%. And in that scenario, the net present value could be negative, and therefore it wouldn't, it's not justified to proceed with the investment. Okay. But it's a good question, and we will come back to that issue as the course progresses. Okay, so that's the separation principle. So this notion of the net present value, it's very useful. And as you can see, it's not a complicated rule. It's quite easy to compute. So it's very widely used in finance. And it will be widely used in this course. You'll have lots of opportunities to calculate net present values. And there are a couple of rules. We've already kind of touched on one. That positive net present value projects should be accepted. So basically, you should invest. If your project has a positive net present value, you should, as a rule, invest in it if you have the money. And if you don't have the money, or say you're looking at a number of different potential projects, and each of them has a positive net present value, then ideally you would invest in all of those projects if you have sufficient funds, okay, because they're all positive net value projects, net present value projects. But if, for example, you're resource constrained, you don't have cash available to invest in all the projects, then you should choose the projects with the highest net present value. Okay, so it gives you, because that gives you the most amount of money in your pocket today. Okay, and that's, as a rational investor, obviously we want to maximize our wealth. We want to maximize the amount of money we have today. Okay. Okay, so let's see. The next topic is arbitrage. So any questions on net present value? Does it all make sense? It's all pretty intuitive, I would think, and kind of not too hard. So what we might do then is take a break for 15 minutes. So it's now 6:45. So let's take a break till 8 o'clock. Oh, sorry, 7 o'clock. Yeah, No, come back at 7 o'clock. Don't remember 8 o'clock. Okay? So,
How are you doing? Good. I don't want to take up too much of your time, but I was hoping you could explain the separation principle to me. So I don't quite understand why you would split those out in an investment decision.
Yeah, well, I guess what we're trying to say is, we can judge the cash flows from a project, and we can, just viewing. Okay, if you're looking at say, investing in a firm, in a new factory or something.
Yep.
You're going to look at, obviously, you're going to have to make an investment at the beginning, and then hopefully, as the years go by, you'll get cash money back. So, what the separation principle says is that those cash flows are independent of how you actually make the initial investment.
Okay.
Whether you borrow money or whether you use your own cash. So, for example, if you have this firm or a factory and it's going to produce cars or whatever, or phones, those cash flows are not going to be dependent in any way about how you raise the capital to build the factory.
Okay. But what if you had, say, like a 50-50 debt to equity split, and you paid your debt back first, and you've got, say, progress payments or interest, and then you've got principal, or you pay the lump sum at the end?
Yes, absolutely.
Wouldn't the investment decision, kind of looking at both of them, determine, whether you can actually pay the debt back?
Well, that comes down to whether somebody will give you the financing to make the investment.
Yeah.
Okay. It still doesn't affect the quality of the investment in the first place.
Yeah,
okay. The factory is still going to be the factory.
Yeah.
Whether the banker believes you will repay them or not, and the factory will still produce these cash flows, whether, irrespective of whether the bank believes you or whoever the factory owner is, are they going to play games when they make the loan repayment?
So it's more in the context of analysing the asset.
Yes, it's very much asset based. Exactly. Yes,
Okay,
exactly. Yeah.
Okay,
Think about the return on assets that you get. So that's going to be independent of whether the firm is leveraged or not.
Yeah.
So
Okay.
you're right. That's
Yeah,
a
no,
good
cool.
way.
When you said it, I was like,
Yeah.
doesn't. Yeah, cool.
Okay, great.
Thank you.
Sounds like you know a little bit about finance. Okay.
I understand the $500 project quite well.
Yes.
But what I don't understand is the $3 billion renovation of the
Okay.
bridge. Yeah,
Yeah.
I still don't get how what's the delay of what's the cost of the delay?
Yeah.
Yeah. Is it so? It's not three. So it's not 0.3 billion.
Well, no, not in $2004. You have to read the question carefully. So they ask you, what is the cost of the delay in $2004?
I see.
So the engineers say if you delay the project, then the project in 2005 will cost 3.3 billion. Exactly. So you have to think, okay, that 300 million in $2005 is not
the same as 300 million in 2004 dollars. You know.
So we're
So two different time periods. You can't compare 300 million in one period with 300 million in another.
yeah, I get that. I
Okay.
get that part.
Yes.
But what I don't understand is how we correlate the $3.3 billion in 2005 to the approximately 3.25 billion in 2004
Yeah.
with the interest rate.
Okay.
I thought we're supposed to use the inflation rate to get the 2004 dollars.
Yeah, okay. Well, you know, the interest rate very often captures
The inflation rate.
but you're right. I mean, we could be more explicit
Yeah.
about that. So you might look at what we call the nominal values and the real values.
Yeah.
You might be familiar. So the
Yeah.
nominal value is 3.3 billion,
right.
and that's without taking into account
The
inflation.
inflation, but with inflation it's more like 3.25 billion.
Yeah, but here we're kind of we're ignoring inflation really, or you know, implicitly the interest rate on some level captures this notion of inflation.
Okay.
Because
I was kind of thrown off by the explanation because I thought by saying inflation, by saying interest rate, I thought the project involves some kind of borrowing from a bank, but that's not the case, right?
no, it's a very simple setup. Okay, it's really to illustrate the point that we can't compare, you know, the 300 million in 2005 does not mean in 2004 dollars, but it's also 300. So it's really very simple. There's nothing too deep in this.
I see. Okay.
But you're right. Maybe inflation is something we should take into account. We don't, in this course, we don't spend a lot of time worrying about inflation. We will briefly touch on it, but we assume that the interest rate takes into account inflation. Because interest rates do, in reality, respond to inflation. If the central bank, Federal Reserve, they believe there's going to be inflation, they're going to increase the interest rate.
Yeah.
Okay.
So just to clarify my understanding from the $500 case that we just discussed.
Yeah.
So in the scenario where we borrow money from the
Yeah.
bank today we borrow $509. We'll pay $550
Yeah.
in 1 year.
That's right.
Yeah, but if we, but in the other scenario, if we borrow 500 today,
Yeah.
we'll pay
Oh,
540.
no. We're not saying. We borrowed 500 today. That's correct. And here we borrowed 509.
Yeah,
Yes.
if we borrow $500 today, we'll
Yes.
pay $540 in 1 year.
Yeah.
So that means $10 profit in the future, but
That's right.
in the today's terms, it's $9.26.
Exactly.
Okay. Just want to clarify.
Yes. Yeah. No, you're. I mean, that's the whole purpose of that little example was to kind of go to and fro between this year and next year, bring money back and forward.
A $10 profit in 1 year doesn't equal $10 profit in today's bank.
Exactly. Yeah. So that's a key point.
Okay.
Yeah.
Thank you.
By the way, you know, all these calculations I make here, I'll be saving them
Yeah, in the elements.
as a PDF.
Yeah. Thank you.
But your writing is probably much easier to read than mine. So,
It's just so that I don't forget.
all right, okay. Well, it's a good habit, maybe, to make notes. Yeah. Okay, so let's resume. So we're finished talking about present value and net present value. We're finished talking about it for today. So we'll obviously come back to it in the future. But the next topic for today is this notion of arbitrage, which is also one of the fundamental concepts of finance. And so earlier we defined arbitrage as the act of buying and selling equivalent goods in different markets to take advantage of a price difference. So if you remember this hand sanitizer example in Chemist Warehouse and eBay. So that definition is pretty intuitive and doesn't need much more explanation. But we do have a more precise definition of what an arbitrage is in finance, and that is it's a transaction that involves no negative cash flows and at least one positive cash flow. Okay? So it basically means that an arbitrage is a transaction where it's impossible to lose money, and in fact it's possible. The only possibility is that you could make money. It doesn't mean you definitely will make money in an arbitrage, but it does mean you definitely won't lose money in an arbitrage. But there's a chance you could make money, okay? So that's what we mean in this second definition here. So let's look at a kind of pretty simple and maybe unrealistic example, but let's illustrate the point. So we have two markets. We have market A, where you can buy or sell gold for $1,200 per ounce. You know, ounce being a unit of weight, in case people didn't know. And then across the street or down the road, you have another market where you can buy or sell gold at $1,000 per ounce. Okay, so $1,200 in one market, $1,000 in another. So how can you take advantage of this opportunity? Is there a possibility of an arbitrage transaction here?
Yes.
Yeah, there is. So what is it? Yeah, so you buy in market B at 1,000 and you sell in market A at 1200, and your profit is 200. Okay. Nice. All right, so that's pretty easy to estimate, but let's consider you can do this costlessly, okay? So what do we mean by costless, a costless strategy? Okay, so remember, in a pure arbitrage transaction, there are no negative cash flows. So, and by no negative cash flows, we mean costless. So that's essentially what costless means. So let's look at this example. So again, it's very simple. Sorry. Excuse me. Yeah. This thing. Okay. Come on. Alrighty. I'll have to do this the hard way. Sorry. Just have to scroll down here. Anybody remember what number slide we're on? Okay. Okay. There we go. All right. So we have the. Okay. Now it's doing something. Okay. So what do we do in this scenario? We can borrow limitlessly for 1 hour. Okay. And generally, I mean, normally you pay interest on an overnight basis. So if you borrow for 1 hour, you know, you borrow at 10 in the morning and return the money at 11 in the morning, typically you won't pay any interest because it's not held, haven't borrowed the money overnight. But still, okay, this is not a very realistic scenario, but this is kind of what we're talking about here. So let's say you borrow $1 billion, okay? So you're going to spend that $1 billion to buy gold in market B at $1,000 per ounce. So how many ounces will you buy? By 1 million, excuse me. So you buy 1 million ounces at $1,000, and then, of course, you go to market A, and then you sell your 1 million ounces at $1,200, and you end up with 1.2 billion. So your profit in that case is 200 million. Okay, so that's a very large profit in 1 hour, isn't it? I mean, so that's a good deal if you can find it. But that's essentially what we mean by costless strategy. So in this scenario, you can borrow money costlessly, make a huge investment in one market, and then exit that investment in another market for a huge profit. So arbitrage, this kind of pure arbitrage strategy, is extremely profitable. Not very realistic. We'll talk a bit more about that in a second, okay? Okay, so what have we done here? In that scenario, we made a $200 million, a zero-cost, risk-free profit for $200 million. All right? So let's have a look at that in kind of our cash flow picture. And again, this isn't very realistic, but I'm just trying to illustrate a result or a notion here. So we have, you know, the beginning of our hour is time 0, the end of our hour is time 1. So how much had we at the beginning of our hour?
1 billion.
We had nothing, because we hadn't borrowed the money yet. We're going to borrow the money during the hour, okay? But then at the end of our hour, we had 200 million. Okay? So what kind of interest rate will get you that return? If you invest 0 and you get 200 million, what's your return on that investment?
100 million.
Well, in percentage terms, I mean. It's undefined. I mean, 0 multiplied by anything will always be 0. So 200 million divided by infinity will get you 0. Okay, so 1 plus r to get our net present value of that 200 million, and to get that net present value to equal 0, you have to divide the 200 million by infinity. So r is equal to infinity here, and or you could say, let's say it's undefined. Your calculator would say when you divide something by 0, it's undefined. Okay, so that's what we mean by a zero-cost risk-free profit. On the other hand, when we talk about a risk-free return, when you put money in a bank, you have the same kind of time frame. Maybe you've got years here, so you put $100 in your bank today, and then say you get your 5% interest rate, and then you get your $105 next year. Okay, so here we are making an investment. We're lending the bank $100. There's a negative cash flow to us in year 0, and then in year 1 we receive a positive cash flow. So we can estimate R here. So it's not, R is not undefined. So that's what we mean. That's the distinction, if you like, kind of a splitting hairs between a risk-free profit, which we associate with a riskless or costless arbitrage strategy, versus a risk-free return, where you lend your money to a secure bank or a secure borrower, if you like, and you know you're going to get your money back at the end of that period. Okay? All right, so this leads us to this notion in finance called the law of one price. So the law of one price states that equivalent assets trading simultaneously in different markets, they must trade for the same price, okay? Because we can't make this costless investment that we associate with the pure arbitrage strategy. Okay, so there must be, if you have equivalent assets trading in two different markets, they must be, by the law of one price, have the same value, have the same price. Okay, so let's look at an example, and we look at a market index. So you're all familiar with market indexes, the S&P 500 in the US, or ASX 200 in Australia. And the market index is really just a list of stocks. It's the list of the biggest stocks trading in a country or in a stock exchange. So the S&P 500, for example, is just the 500 biggest firms by market value that trade on the New York Stock Exchange. Okay, so the index is really just a list. So you often hear people talking about, say, investors talking about buying the index. But what they mean when they say that is they want to invest in the stocks that are on the list of firms associated with the index. So that means they have two choices. The first choice is they buy each individual stock. They buy a share in each individual stock that's listed on the stock market or listed on the index. And the other option they have is to buy a stock in an exchange-traded fund that tracks the index. Okay, so have you heard of exchange-traded funds? Some of you have, some of you haven't. So what is an exchange-traded fund? Well, an exchange-traded fund, it's a mutual fund. Again, you can buy and sell shares in exchange-traded funds on the stock market itself. And these mutual funds they're designed to mimic the market indexes. So what happens when you buy a share in an ETF is that the fund manager or the authorized provider of the ETF, they go out and they buy the individual stocks that belong to the index that the ETF is tracking, okay? So for you as an investor, it's much easier to buy one stock in an ETF than to buy all 500 stocks on the S&P 500, and so your fund manager will take care of all that horrible work to buy those 500 stocks, okay? And then similarly, when you sell your share in your ETF, the fund manager will then go and sell the individual stocks associated with the index that the ETF is tracking, okay? So, so can you see where we're going here? We're looking for a potential, is there a potential arbitrage strategy here? So, for example, what price should the ETF be? What should be the market price of one share in the ETF relative to the shares in the index? So remember, you have 500 shares in the index, and each share has its own market price, and the fund manager is going to buy one share in the index. So the price of the share in the ETF should be the average? No, it should be the sum of the prices, because the fund manager is going to buy one share in each stock on the index. Okay, so he has to spend the sum of the share prices of each stock. Okay. Yeah. So therefore, that means there's a potential arbitrage strategy, isn't there? For example, if the price of the ETF is not the same as the sum of the prices of each stock in the index, then by the law of one price, those two assets should have the same value, shouldn't it? Because they're basically equivalent assets. So you have your index. It consists of all these individual stocks, and the price is the sum of the prices of these stocks. And then you have the ETF, but you just buy one share of the ETF, and when you buy that one share, you own one share of each stock in the index. Okay, so it should be the same, shouldn't it? But sometimes, and this is maybe more realistic than the gold example, is that we see that the price of the ETF is different from the sum of the prices of the firms in the index. Okay, so let's look at let's just make again a very simplified example. So we have this all ordinaries index, and the index just has two stocks, and the two stocks are ANZ, which is trading for $20 a share, and BHP, which is trading for $50, okay? So, by the law of one price, what should the price of the ETF be? 70, exactly, yeah. So, the price of the ETF should equal the price of ANZ plus the price of BHP is equal to 50 plus 20 is equal to 70. Okay, right. So the arbitrage opportunity would be if these two are not the same. If they're not equal, that implies there's an arbitrage. So you do see this kind of scenario in the real world from time to time. So things get a little bit out of kilter, prices don't update quickly enough. Okay, so how would you take advantage of this price, of this scenario? Let's say the price of the ETF was, let's say the price of the ETF, excuse me, let's say the price of the ETF was 80, and the price of ANZ plus BHP is as we have above. So let's say it's equal to 70. So how would we, if we were investors and we're traders, how would we take advantage of that scenario? What transactions would you execute? What buy and sell transactions would you execute? Which would you buy, which would you sell? You're saying buy these two and sell this one? Exactly, yes. And what profit will you make? $10. Okay, good, yes. That's exactly, you execute the two transactions, okay? But let's say you don't have this ETF in your portfolio, so you actually haven't bought this ETF before, but you observe that the prices here are different, okay? So what do you do then? We talk about selling the ETF, and the term in finance that's used for that, when you sell something you don't actually own, is you short sell it, okay? So we call it short selling, okay? So how many of you are familiar with this notion of short selling and how it works? Okay, a few of you. Okay, but we'll just illustrate or describe what we mean by short selling. But before we do that, we'll introduce two other terms. When we talk about buying a stock on the stock market, we talk about going long on that stock, okay? So you might have heard the term going long, so that means buying the stock. And then to short a stock essentially means to sell it, even though you may not have it, you may not own it, but there is a mechanism where you can sell a stock that you think looks overpriced. So how does shorting work? Well, the way it works is like this. You find somebody who owns the stock that you want to short, okay? In our case, we want to short the ETF. So you find somebody who owns that ETF, and you ask them, can you borrow their stock off them? And if they're holding that stock for many years and plan to continue to hold the stock, to say, okay, sure, I'll let you borrow it so long as you give it back to me in a reasonably short period of time. Okay, so you borrow your stock from somebody who actually does own it, from somebody who has a long position in stock, right? And then you sell that stock that you've borrowed. So you get the money in your account, you get the price of the stock into your bank account, but then there's a catch. You have to pay the person you borrowed the stock off, you have to give them some fee, because they're not going to just lend it to you for nothing. There has to be something in it for them. So they get a fee, or this thing called the rebate rate. And while you have borrowed the stock from that person or that broker, typically, you have to repay any dividends you receive on the stock while you've borrowed it. And then when you are closing the transaction, you have to basically buy back the shares that you sold and give them back to the lender. Okay? So an example is this. So let's say you observe stock A at time 0, and it's trading for $50, right? But you think that stock is overvalued, so you want to short sell it. You think that in 1 year the stock is going to be worth $40, right? So you think the price of the stock is going to go down. Okay, so you want to short sell. So you find a broker or somebody to lend you the stock. So you sell that stock then, and into your bank account you receive $50 from selling that stock. But then you have to pay the lender a fee, let's say it's $1. So you end up, you just then have $49 in your account. And then let's say the stock pays $2 dividend during the time that you have borrowed it. So you have to pay that $2 back to the owner of the stock. So you end up with just $47 in your bank account, okay? And then in t equals 1, you want to, you believe, hopefully the stock price has fallen from $50 to $40. So what do you do in that scenario? And at t equals 1, then you buy the stock back at $40. So the money in your bank account goes from $47 minus 40 to $7. Okay? So that's your profit on this short sale transaction. Okay? So that's how short selling works. Okay. Any questions on that? Okay. So back to arbitrage. So the question is, do arbitrage opportunities exist? Well, in finance, we assume they do not. It's pretty hard, especially those costless arbitrage transactions that we had in, for example, the gold example, where you have two markets. Costless arbitrage, cannot exist really in finance, that kind of, because you cannot make a profit on a $0 investment. So by the law, it's impossible. And in any case, what would happen in the gold example? If, say, you could borrow limitlessly, what would happen to prices in the two markets? So you're going to be buying gold at the $1,000 price and selling it at $1,200. So how long is that situation going to last?
The price isn't short.
Sorry?
The prices doesn't short.
It's not going to last very long, because you're going to have, you won't be the only person to spot this opportunity. So you're going to have lots of people rushing in to make that trade, and the people in market A and market B are going to adjust their prices. You have a lot of buyers coming in to buy at $1,000. So what happens when when demand is higher than supply, price goes up. And likewise in market A, where people are selling a lot of gold at $1,200, that's going to push the price down. So the prices will converge. And that's what happens in the real world, that when you have these opportunities, if you're lucky enough to observe an arbitrage opportunity, it's not going to last long. A lot of other people are going to see that opportunity, and they're going to rush in, and the prices are going to adjust very quickly, instantly. The way I think about arbitrage is it's a bit like finding money. If you find money, it doesn't cost you anything, but it's money in your pocket. But it doesn't happen very often. Very rarely happens that people leave money lying around. And generally, if they do leave money lying around, it's not going to be a large amount of money. It might be $5 or $10. So you might observe arbitrage opportunities in the real world, but they're going to be for small amounts at best, and those arbitrage opportunities are not going to last very long. Okay? that said, you do have people who do what we call risky arbitrage. So the pure definition of arbitrage is where there's no possibility of losing money. But there are arbitrage strategies which are risky, where there is some possibility of losing money, but there's also a possibility that you make money. You know, we talked about the long-short arbitrage, where you go long in one market, short in another. You know, in the gold market, those don't exist. Those kind of costless opportunities don't exist. But there are a lot of firms, hedge funds usually, who execute these risky long-short strategies. And these risky long-short strategies are also called arbitrage strategies, even though they're not risk-free. Okay? So what these strategies try to do is just identify these mispricing of assets in different markets and to take advantage of that mispricing. Okay? All right, so that's, yeah, let's look at it. There are a couple of examples that we can talk about. You know, these are real examples that have occurred in the past. So you may not have heard of these firms, but there was a firm called 3Com who made networking equipment in the 1990s. And 3Com bought a company called Palm. And Palm was a very hot company in the 1990s. Palm made what we call personal digital assistants. Does anybody know what a PDA is or heard of a PDA? Yeah, well, it's something. So it's basically a PDA is essentially a mobile phone without the phone. So you can make notes or you can make recordings, that kind of stuff. So it was a very hot product in the 1990s. Mobile phone technology didn't exist. So when 3Com bought Palm, they got a good deal. They bought Palm when it was still a new company. And then after a few years, 3Com decided to sell Palm, to list it on the stock market. So 3Com itself was also listed on the stock market. So what happened was, you know, so we have this kind of setup. You had Palm in its little bubble here, and then we had 3Com here. Oops, sorry, I'll get rid of that. So 3Com owned Palm, right? But what actually happened when Palm was listed on the stock market, that the market value of Palm was greater than the market value of 3Com. Even though 3Com owned Palm, but the markets, for some reason, thought Palm was worth more than, you know, do you get the problem? You know, that this firm owned another firm and the value of the firm that it owned was greater than it. So it didn't make any sense. So a lot of people perceive this as an arbitrage strategy. And what would the arbitrage strategy be? Yes. Well, you have to make two transactions. You have to buy one stock and sell the other. Which one would you buy? You buy 3Com and sell Palm. Okay. So a lot of people were looking to make this transaction. And, you know, we talked about selling short and how that works. So the reason this arbitrage opportunity seemed to persist was a mystery until somebody realized that actually what was happening was that the fee arbitrageurs had to pay to borrow Palm stock in order to sell it short was so high that it offset the profit that they would have made making the arbitrage trade, okay? So it meant that there was no profit to be made in making this arbitrage trade, that the fee associated, you know, the rebate cost of short selling was too high, okay? So this situation persisted for several weeks or several months, and it was kind of a mystery in finance circles why it was going on, but eventually somebody realized what was happening. So you do observe that kind of thing happening from time to time. Another example of an arbitrage scenario is this thing called merger arbitrage, and you do see this quite a bit. So the situation is where you have one firm that's going to acquire another firm, okay? And usually when a firm announces that it's going to acquire another firm, the share price of the buyer firm drops and the share price of the target firm goes up. And the reason the share price of the target firm goes up is because usually the buyer is paying a significant premium above the current market price of that firm. Or else, the directors of that company, they wouldn't sell otherwise unless they were getting a significant premium over the current stock price. And likewise, the inverse occurs for the buyer because the owners of the stock of the buyer, think the firm is overpaying for this target company. The premium is too high, so they're not happy. So they sell the stock of the buyer firm, and that pushes the stock of the buyer firm down. So let's look at it. For example, let's say Apple wanted to acquire Nokia, right? Nokia, the troubled Finnish telephone maker. So if Apple announced that they wanted to buy Nokia, usually what would happen is the stock price of Apple would drop and the stock price of Nokia would go up. So what's the arbitrage opportunity? You hear this rumor, through your friends that Apple might be buying Nokia. It's not publicly known yet. So what do you do? Yeah, you buy Nokia because the stock price of Nokia is going to go up, right? And you short sell Apple because you believe once this merger is announced, the price of Apple is going to drop, the price of Nokia is going to go up. So you're going to make money, okay? Because the prices will kind of converge. But you have to be careful. You have to make sure you do this trade before the merger is announced. Because once the merger is announced, the prices will adjust. Once it's public knowledge, the prices will adjust. So the strategy here is, whoops. Again, this thing isn't, whoops. Okay. No, there's a quicker way of doing this, but it's not working for me today. Okay, so here's the merger. So the strategy here is buy the target company, buy Nokia, and sell Apple, buy the acquirer, sell the acquirer. That's Apple. And then after the merger is announced, the price of Apple will drop, so you make money on your short position, and the price of Nokia will rise, so you make money on the long position, okay? So make sure you do it before the merger is announced, or you won't make any money. So if you're interested in this notion of arbitrage, this is a book that I would recommend for anybody who's passionate about finance and understanding how hedge funds operate. It's a book about a firm called Long-Term Capital Management. And this was a hedge fund in the 1990s that was run by a very small group of people, maybe 50 or 100 guys, two of which were Nobel Prize winners. So they came up with all these arbitrage strategies. that were as close to being risk-free as they could manage. And for a while, they were extremely successful. They made huge profits for their investors. But then the Asian crisis occurred and their arbitrage strategies went wrong. So the whole thing went bust and they had to be bailed out. So this book is a fascinating story. It's written for really a non-financial person. And it's probably one of the books that kind of got me interested and passionate about finance. So I'm just giving it a little plug there for anybody out there who might be interested in this kind of thing. So our last topic today is risk and uncertainty. So if you remember, we mentioned that there are two fundamental concepts in finance. One was the time value of money, the other was arbitrage, and they're the two concepts that are covered in the book. But here today we add a third concept, and it's called risk. And we kind of touched on it already when we looked at our promised cash flows at the beginning in our little thought experiment. You know, how risky a future cash flow can be, and how does that change our perception of the value of those future cash flows. So we'll talk just very briefly about that. So we have this notion of risk, and by risk we mean that the size and timing of future cash flows are not known today, or even if they will occur at all. But how do we measure, or how do we account for this uncertainty or this risk about cash flows? So there's a very interesting experiment which we will now do. Again, it's a thought experiment. So you have, and the setup is this: you have two buckets or urns. So urn is just a fancy name for a bucket. And in the first urn, you have 100 balls. Some of them are red, some of them are black, but you don't know how many are red or how many are black, okay? And then in the second urn, you have 50 red balls and 50 black balls. So you know exactly what the ratio is. So the game is that given that you have to choose a color to draw, which urn would you choose to maximize getting that color? And if you get it right, if the correct color, if the color that you're looking for is drawn from the bucket that you want, you receive $100, okay? If you don't get it right, you get nothing, okay? So you don't lose any money. But obviously you want the $100, okay? So there are two scenarios. In the first scenario, you're given a choice. You want to draw a red ball. So which urn would you choose to maximize the possibility of drawing a red ball? Yeah, so let's see, let's do a quick show of hands. Who would choose the first urn? Who would choose the second urn? Okay, that's unambiguous. The vast majority of you would choose the second urn. And then let's say we finish that game and we put the ball back, and then we have a new game. And in this game, we want to choose a black ball. We want to choose. So which urn would we pick if we want to maximize the possibility of choosing a black ball? How many people would choose the first urn? How many people would choose the second urn? Okay, again, the vast majority of you. But the result will be a little bit surprising. So this experiment is known as the Ellsberg paradox, and it's a paradox, which means it's an unexpected result. And why is that? Okay, so to draw a red ball, in the first case, you were asked to draw a red ball. So most of you chose the second urn, where you know there's 50-50 mix. So that means that you believe that the red ball, that the second urn has more than 50 red balls, okay? Anybody argue with that? Everybody okay with that? Okay, so then in the second case, where you had to choose the urn from which to draw a black ball, again you chose the second urn where the ratio was known between the red and the black balls. So what are you saying there? So you're trying to choose a black ball. So that means you must believe there are more black balls in the second urn than there are in the first. So what that means in reality is it means you believe there are more than 50 black balls in urn 2, right? Anybody disagree with that?
How can there be more than 50?
Well, no, we're not saying there are more.
Okay.
What we're saying is that this is the paradox, that basically based on the unambiguous vote that we had in both cases, that in case 1, the vote implied that there's more than 50 balls in... Sorry, maybe it might be clearer if I had it the other way around. Anyway. So yeah, so I have it... maybe I'll make this a bit more clear. Obviously you're not going to... Let's say you've more than 50 balls in 50 black balls in urn 2. Sorry, urn 1. So you know the ratio in urn 2, you don't know the ratio in urn 1. So you're guessing the ratio in urn 1. So when you guess the ratio in urn 1, you're guessing that there are fewer red balls in urn 1 than there are in urn 2. Okay, so I have it right now. Okay, so in the first case, you're guessing that there are fewer red balls in urn 1 than there are in urn 2, so that means that there's more than 50 black balls in urn 1, okay? And the reverse is true for the second case, okay? So you believe that there's more than 50 red balls in urn 1. So that means, urn 1. So that means you have more than 100 balls in urn 1. But we know that's not the case. We know there are 100 balls in urn 1. So do you get the paradox that it's kind of... It's one of these human psychology things that it goes back to this knowledge of what the ratio is. Here in urn 2, we know that the ratio is 50-50. And on a human level, we like to know what the ratio is before, when we guess an outcome. And so we know what the probability is here, okay? So how does that translate into finance? Well, it basically means that humans, we don't like uncertainty, we do like knowing the probabilities, okay? And in finance, it's similar. So when we look at risk in finance, we want to know what the probability of a cash flow is. We don't like uncertainty about cash flows. And in finance, we assume that we know the probabilities much more often than realistically we can know the probabilities. So we end up with the situation that we feel more confident in a risky situation than maybe we should when the situation is uncertain, okay? Okay, so so that's really the message there, that we live in a world of uncertainty, but in finance we assume that we do know the probabilities of outcomes in the future, okay? So finally, our last slide for today, we will look in more detail at risk the risk of assets, the risk associated with stocks, you know, and how we can manage risk. We look at risk relative to other stocks. For example, is the risk associated with an individual stock more or less than the risk of a portfolio of stocks? You know, is the risk as we associate with the portfolio of stocks, is that the sum of the risk of the individual stocks? And we will show later in the course that the risk of a portfolio of stocks is actually less than the sum of the risks of the individual stocks. So, so we will be looking at that later, and then we also, in terms of risk, you have to be aware of people's individual risk aversion. So again, an thought experiment at the beginning, we saw that some people have different levels of risk aversion. That some people might be prepared to lend me $100 today. Some people might not be prepared to do that. Okay. All right. So that's it for today. So we'll see you next week, same time, same place. Next week we will do the workshop exercises. So do please take a look at them, and we'll go through them in the first hour of the session next week. Well, in risk, you know the probability. So you know so a risky cash flow, you think you know what the probability of that cash flow occurring will be. So it's a bit like
risk. If we select the earn 2 means
yeah.
we take risk.
Yeah, so earn 2 is risk. You know the probability, so it's 50-50.
But earn 1 was uncertain.
Exactly, yes. Okay, well, thanks for asking. So I'll make sure. I'm sorry I didn't make that clear. Hi.
Question. You left me wondering, what happens like there are much ETFs, which price of the share of the ETF is not the same as the sum of all the shares involved. So is there an opportunity of an arbitrage there, or?
Yes, there is.
Like that.
So I thought, you know, if the price of the ETF is greater or less, if the price of the ETF is different from the price of the sum of the stocks, then there's an arbitrage opportunity. So the price of the ETF must be the same as the sum of the prices of the stocks.
But on the ETF that holds the S&P 500, I don't think that's the case.
Well, you know, do you want to discuss specifics?
Well, not at that level.
Yeah, it might depend on how the ETF is structured. If the ETF, I mean, the one we were talking about here is where you had an equal weighted portfolio, so you buy one share of each stock.
Okay.
I don't know which ETF you're thinking of, but it could be that it buys the value weighted. Instead of buying one stock of each company, it buys a value weighted
like a piece of the stock.
Well, yes, or it buys stocks in different proportions. For example, we know that Apple represents 10% of the stock market, whereas a smaller company, I don't know, some small S&P 500 company, let's say it's a real estate company, is worth 1% of the stock market. So how many shares would you buy? You buy 10 Apple shares
and you'd buy one real estate company share. So the ratio of shares could be different.
Oh, okay.
So but you have to look carefully at the small print about the ETF.
Okay.
So you want to, it will specify what algorithm or what approach it uses to buy the stocks that the ETF holds.
Okay.
But the simple examples that we covered, we just assumed
Yes.
it bought one stock of each share.
Okay. Well, thank you.
Okay.
See you next week.
Yeah. Okay, no worries. Hello.
Just wondering, does the workshop conduct the same kind of a lecture? Or-
Yes.
Oh.
It's the first hour of the lecture.
Okay, so any tutorial class for this?
There's no separate tutorial class. No.
Alright. Thank you.
Okay.
Repeat that.
No, I'm looking for it.
Yeah. Thanks, Mark.
Okay, cheers.
Thanks, mate.
Take it easy.